So hello from our side and welcome to our talk about testing in the field of MLOps. Okay, let's start. We have to start with a sorry. If you expect this talk about general tests in AI, this is not the focus of our talk. This means model validation, model evaluation, model performance, or even machine learning metrics are not central topics of our talk. So all these topics are big enough to fill thousands of other talks, but it's not our focus. So if you're very, very disappointed now, we can make you an offer. Stay here and listen to our talk, because we got plenty of nice other topics. You have the chance to listen on our perspective of machine learning ops specific tests. And this means we give you a brief overview of how tests helps us in our daily work. And in detail, we'll talk about unit tests, about code quality, contract tests, what else? Infrastructure tests, pipeline tests, endpoint deployment tests, and last but not least, a few slides about monitoring and logging. So quite a bunch. And before we jump in, let's introduce ourselves. Tobias, standing next to me. Tobias got a PhD in computer vision and has been working with idealo as a machine learning engineer for the last 4 years. My name is Gunar. I got a diploma in computer science and have been working at idealo for almost 9 years now, and also work as a machine learning engineer. Okay, so idealo. Here are a few key facts about idealo. Idealo is a price comparison from Berlin with more than 20 years of experience now. And in our manually curated catalog, users can find more than 4 million online products within 2,000 categories. So quite a lot. And idealo collects all these offers from over 50,000 shops. And what happens to these offers? They are processed and then presented to our users that they feel well informed and they got good hints about their shopping decision. And one of our key tasks is cataloging the whole shop offers. And this means processing. And this is how it works in general, but simplified. So idealo imports all the offers from very different shops. Yes, there are small shops, there are big shops, there are very big shops, tiny shops, so all sizes of shops. And these shop offers may contain a description text, for instance, some identifier, or even suggestions for our cataloging system. And our task now is to map these offers, the shop offers, into our catalog. Yeah? And cataloging can be divided into several subtasks. There's category classification, yeah? And there's attribute recognition. So, for instance, extract the color or the size of a t-shirt, for instance, or some technical attributes of a washing machine or photo camera or what else. And there's also offer product matching, so shop offer product matching. This means match a product within our catalog within shop offer. And there are also a few more subtasks of cataloging. And what's cool is that all these subtasks can be solved by machine learning, so our domain. And if you look at machine learning, the use of machine learning is usually very specific, and it varies from case to use case. So you got early project phases where the use case or the business goal is more on focus. Yeah? And later, the exploratory data analysis is more important. And once these things have been clarified, then other things such as selecting a suitable algorithm or generating the features become more important. Yeah? And even later, it's about getting things running, deploying the model and ensuring that operations run. And as soon as operations are stable, it is a matter of continuously updating the model yeah, and feeding it with new data and continually deploying new models. Yeah? And this continuous sequence of repeating steps, this can be represented by the so-called machine learning operations lifecycle. So our team implemented this MLOps lifecycle and ended up in a machine learning pipeline, yeah, for our category classification task, for instance. Yeah? And in detail, the whole ML pipeline works like this. According to the lifecycle, there are separate components, yeah, for data, one for model, and one component for the endpoint. And each component got a separate code base. Yeah? And these separate code bases allow us a great flexibility and also a good development speed. Yeah. By the way, we use Renovate to update our third-party libraries. And yeah, we even allow Renovate to deploy our components yeah, continuously. And what else? Yeah, some more aspects. Our training pipeline is triggered every 2 weeks continuously. The endpoint is running 24/7, so all day, all night, and we process up to 2 billion offers per week in peak time. So, and as you can imagine, a 24/7 running system should be as stable as possible. And otherwise, you might a call at midnight, or your colleagues might get a call at midnight, and this is something nobody wants. Yeah? And there's another aspect, that each component depends not only on its code base, yeah, but also on the output of its prior component. Yeah? And a minor change at the beginning of the pipeline might have a huge impact on the whole running system. And therefore, the lifecycle might be good in theory, but it can be quite fragile in practice. So, if you end up like this, what shall you do? Yeah? Can you put things in the right order, or is there a way to fix the lifecycle? And with these questions, I hand over to Tobias, who hopefully helps us to find an answer.
Thank you. The answer that we want to give to that is testing. In the following, I would like to share our experiences in testing with machine learning. So why is testing important? For a software developer, testing is a daily business and forms the basis for a maintainable and reliable software product. But as a former researcher, which I was, I struggled a bit in applying testing concept to machine learning. But when we put machine learning pipelines into production, testing becomes unavoidable. However, writing tests in machine learning domain is very challenging, because the testing behavior of a machine learning system not only depends on the code, it also depends on the data and on the model artifacts. And these artifacts are not available at test time most of the times if they are very big. Yeah, I would like to give you an overview about tests we use in this talk. I put our tests in this testing pyramid. The higher you get in the pyramid, the longer the processing time will take. And we hope that we can detect errors on a very early stage here in, okay, you don't see this, in the place below. But also the higher you get in the testing pyramid, the more certain you are that the software is correct. In our case, we identified 3 testing domains, which is in black. These are classical software tests, which are unit tests, config tests, and we put also linting here. And then we have tests that are related to our cloud setup, which are the infrastructure as code tests and pipeline tests. And finally, what we do is machine learning related tests. So we test the data, the model, and we do kind of end-to-endpoint tests for our classifier services. As Gunar said, we will not dig very deep into model testing, and we will also not present some sophisticated deep learning related tests, because of course this field is evolving a lot in the recent years, but we want to concentrate on the operational point of views. If you'd like to read further into the topic, I brought you here below a link. This was a nice presentation on the last year conference, on this year, in this conference, which is explicitly about deep learning tests. Okay, I would like to start in our pyramid with unit tests and linting. Both apply directly to the code base, and unit tests especially run on individual components in the code. That means they are quite fast and they allow you to identify errors on a very early stage. I brought you an example, yeah, you can see that, of a classifier endpoint implementation, which is very simplified. What we're doing here is that we want to predict a category for an idealo offer. We have an input scheme, which is due to our inference services, and we do some pre-processing where we connect like title and description to a text, and we put this text then in an sklearning model. This can be a support vector machine or whatever you like. And this is a unit test code for this example. We are doing unit tests with PyTest, and here we want to show you some techniques which we like in that. The first technique is called fixtures. Fixtures run before the test only once, and then they can be used to initialize data and also object. In this case, we initialize a dummy classification object where we do some configuration loading, data pre-processing, and you can use the fixture method to pass it directly into our testing function as argument and then work with that. And this is only done once for all the tests that you use. The second thing is the parameterization decorator. This decorator allows you to run the test function multiple times with multiple data points, which can be also edge cases. In our case, here we test the internal pre-processing function and provide some input data and text data for that. Yeah, and as I said, the nice thing is that you don't have to implement a loop which goes over all the data points. You just have to can use this parameter, and the tasks are run parallel. Yeah, and the most important technique that we like to use is mocking. Mocking allows you to override specific function, especially for large models. As I said, we are not able to load them during the test time, and we use mocking most of the time to fake the model output predictions. The PyTest mocks allows you to mock the output. I mean, you provide a return value of the mocked function, and in our case here, we just checked if the return value of the model is passed correctly with our classifier function. And mocks also allow to check the input argument of our mocked function. In this case, we checked if the pre-processing return value was passed correctly in the mocked function. However, mocking has to be really taken with care because if you mock everything, and that could sometimes be by accident, then you remove all the logic tests in your code. So mocking can be tricky. Okay. The next method I would like to speak about is linting. Linters are tools to improve the code quality. That means they can check typings, they can check formattings and spellings, and we have good experiences with the superlinter, which is a package that contains a lot of linters. We like, for example, the Flake 8, Blake, ISOT, and MyPylinter. And another advantage of this package is that they offer a GitHub action, which makes it really, really easy to integrate it to a CI/CD pipeline. And when we start using linting, we found that it also helps us to detect errors in the code on a very early stage. In this example, you see that somehow we forgot to implement the preprocessing function. And this was detected by the MyPylinter because the input argument, which is in the preprocessing, which is directly passed in the output, does not fit from the type. And this is detected by MyPy, so linting can be also an additional safeguard. All right. The next step next test I want to talk about is contract tests. In our case, we have to consider that the classifier server is only a small part of our cataloging domain. Although the domain is owned by our team, but most of the components are integrated in an event-driven asynchronous architecture. That means they are connected to Kafka and MongoDBs and all this stuff, and they run on an EKS cluster. And most of the services are not implemented in Python, they are implemented in Kotlin, and most of the services are not implemented by Gunar and myself, they are implemented by our colleagues, which are experienced software developers. And although we work very closely together, there are differences in the Python world and in the Kotlin world or in other languages worlds. And these differences can lead to misunderstandings. And therefore, we take care that we define our interfaces with care, but as we are human beings, we make mistakes. And one case that we had is that there was an error in the transmission of an ID, so we expected an int and got a string, and this error led then to errors in the conversation, so the model predicted an offer based on wrong ID, and this screwed up totally our classification. And this was, for us, really difficult to detect, because a long time we thought that it depends on the model, we have screwed up something with the training, but it was just this conversation error in the interface. And contract tests are a nice solution to test the interactions between services. How does they work? Contract tests exchange contracts, and these contracts are similar to API specification files. They are exchanged with a broker, and we use the packet flow server for that. And in our case, the consumer, which is within Kotlin, defines this API specification, and then we have to verify this contract on the classification side. The nice thing about contract tests is that they are run at unit test level. That means they execute really fast. So we don't have to do some complex integrations tests here. And in the above example, I brought you a piece of code where we implemented this verification with a package which is called pacman in Python. As you see, what you have to do there is that you implement a dummy server, then you have this verification method, and then you can get a verification response which contains the content of the contract, and this we validate in our input scheme against this verification server response, and we see if everything is okay. But APIs are not the only place in our pipeline where the consistency of data formats plays an important role. In our machine learning life cycle, the training and validation and test data is processed in several services. And these services are developed independently. And this can result to unexpected data changes, and this can make problems. A case that we had is that we had problems in our auxiliary validation data, and this leads to problems in the training. The problem here was that we only recognize this error at the end of the model training, and for us this takes 2 days. Yeah, 2 days. So the code crashed after 2 days, which was really annoying, and that was due to wrong data format. Therefore, we implement data consistency checks, and these checks are applied to all the data that goes in or out the service, and this is data which is stored on S3 in a S3 bucket, like in CSV files or Parquet files. And we concentrate on validating data schemes, and our idea was to implement a very, very simplified data contract. In fact, we use the same framework, we use a packet flow server, and we create contracts that contain data scheme definitions. And we can use these definitions to synchronize the data we store on the model training with the data collection service. Good thing is here that everything runs with unit tests, and another advantage of this approach is that on both sides, on the model training and at the data collection, we now have the data scheme, and we can use the scheme to generate mocking data. So also the data we use to mocking in both services are synchronized, which makes the unit tests better at the end. And with that, I would like to hand over to Gunar again, who will explain the next test.
Thank you. Next tests we do are infrastructure as code tests with snapshot tests. As you can imagine, all our infrastructure of the pipeline is in the cloud, is running in the cloud. And in our case, infrastructure means that we use CloudWatch for logging and monitoring our SageMaker components. The SageMaker pipeline itself, it's part of the infrastructure. We have several buckets for our data, and even our models are stored in buckets. The SageMaker endpoint is part of our infrastructure, and last but not least, all this access management is also part of our code and our infrastructure. So as we said, all infrastructure is defined as code. What does it mean? We got some code, and this code is filled via configuration parameters. Yeah? And then it will be deployed. Yeah? And this allows us a very great flexibility, scalability, and much more. And by the way, we use the Cloud Development Kit, CDK for short, that has established in our team on both sides, Kotlin developers and Python developers. So what does it mean? The current state of the deployed infrastructure is defined in a snapshot. Yeah, so the snapshot is the state of the infrastructure we want to deploy. And a snapshot test means if I deploy my coded infrastructure now, does it match with my current snapshot? Yeah, and if it matches, it's cool. But if not, then there are two options. It's intended, then it's cool as well. But if it's unattended, then you got a problem. Yeah. So if there are unattended changes, maybe in the configuration that you don't want. Yeah. For instance, a typo might lead to an unwanted instance to be deployed. Yeah, and this instance might be much too large for your use case, yeah, and much too large instance type generates a bunch of unwanted cores. Yeah, so real problem. This is an example of our CDK implementation. So on the left side you see this CDK code, and we have for testing purposes, we replaced a config parameter just by a fixed string, yeah, just for testing. And unfortunately, we didn't revert our changes. Yeah? So it was as it was, and we, the wrong name was still in our code base. Yeah? This might happen sometime. And luckily, we had this snapshot test, and before the next deployment came, it was failed, and you can see on the right side the output of the snapshot test, and it's like a diff. Yeah, you can read it like a diff. So the difference between the snapshot, yeah, and the state of the infrastructure that you want to deploy. Yeah, so the unwanted name change was detected by the snapshot test, and we were fine. Okay, so let's jump to the next level of the pyramid. As you have seen, SageMaker pipelines are a very essential part of our lifecycle, and therefore it's very important that they are stable. And in case of changes of our code base, we always want to make sure that the pipeline is still running. Yeah? And on the right side, you see a screenshot of one of our model building pipelines. So it contains multiple steps and branches at each single points. And some of these steps are running on dedicated instances. And those instances might have a 3-minute warm-up phase. Yeah? So as you can imagine, the whole pipeline, it takes a while to process from start till end. Yeah? And therefore, we sampled a very, very tiny data set that runs through the whole pipeline. And in error case, we want to get notified as soon as possible. Then model test. Yeah. So as Tobias said, we identified some edge cases our model is confronted with from time to time. So maybe a shop offer might be corrupted. And this means the information it contains makes no sense. Or a shop offer might have a lack of information. There's no relevant feature that might be extracted. This is called an unseen sample. So in our case, it's a model that classifies a shop offer as a rebuild or a no rebuild. So what's a rebuild? There are some categories where rebuild products are quite common. Printer cartridges or vacuum cleaner bags, just to mention some of them. And the question arises in such edge cases, what shall the model predict? And the answer should always be driven by your use case. So what we did was we expect the model classification to be an error. And the question is, what error has the lowest cost? Yeah? And make the error with the lowest cost as the default prediction of your model. Yeah? So in our case, the default answer is no rebuild, because if we misclassify a rebuild as no rebuild, the cost is not as high as if we misclassify a no rebuild offer as rebuild. Yeah? But it depends, of course, on the use case. Okay, we reached the top of the pyramid, endpoint deployment tests. As we already mentioned, model and deployment are developed independently and have separate code bases. And both code bases reference the same third-party libraries. TensorFlow, Pandas, NumPy, just to mention some. And there might be, from time to time, a version difference between the two code bases, because they are independent of each other. And this can result in this situation. The service provides a slightly modified result than the model provides. For instance, a different class on the same shop data, or same class but different confidence score. And it's hard to detect such a difference, because everything runs smooth. And but that makes it quite dangerous. But we detected this behavior, and we eliminated those inconsistencies with doing the following. When we deliver our model, we always deliver it with a reduced set of validation data. And this contains the input data and the output of our model to deploy. And before we deploy a model to the production endpoint, we always do take the input data and throw it against the endpoint, and then compare the model results with the endpoint results. And if there is a difference, we stop the deployment and have to look what's the reason for it. But if the difference is not, then we are sure that endpoint and model are consistent. Then we have model stress test. So in regular intervals, we have a very high traffic on our systems. As we mentioned, in peak times, we have to process up to 2 billion shop offers by week. And our services, on the other side, process offers in batches for faster processing. And if we got huge traffic, the batch size will increase to be able to process all the additional data in an acceptable time. And what might happen is that the increased batch size can lead to a following situation. There are some machine learning models that use sparse matrices for calculation, support vector machine, for instance. And sparse matrices are very, very large vector spaces with many, many zeros inside. And to save space on this, they are compressed. But during runtime, they are full decompressed and require the full space in the memory of the instance for a fast calculation. And what happens is when big traffic comes, then the batch size will increase. And with an increased batch size, the memory requirement of our deployed instance will also increase. And sometimes the required memory exceeds the memory of the instance where the model shall run. So, and what happens is that the service stops working and can no longer be initiated. This shall not be. So AWS, on the other side, offers, when you deploy models via SageMaker and AWS, this is done by blue-green model deployment. This means a new model is deployed on the same infrastructure as the old one. And if it's stable, then the old model is removed gradually. That's good, but does not prevent us in such an edge case. So what we do, we stress our model before we deploy it. And this means we take a multiple of typical traffic and see if instance type is able to host our model under stress. And if this pass, cool, model is good and instance type is big enough to hold the model. If not, we think about a bigger instance type or try to build a smaller model. Okay, that's it from our test perspective, but there is still one aspect left to have a stable and reliable system, and Tobias will tell you more about this.
Yeah, this aspect is monitoring and logging. From our point of view, monitoring and logging is essential for a safe operation of software product. But I think it's nothing new for most of you. But it's not only important to create nice boards, it's also important to check the boards on a regular basis and create nice routines to doing that. For example, we check our boards every morning in our dailies, and we nominate something which is called like a watcher or babysitter of a week, who is responsible for the boards in that week. And this is also the product owner and the team lead. They are involved too. Yeah. For monitoring, we use Grafana in combination with the CloudWatch metrics on AWS. We classify our metrics in operational metrics, training data metrics, and model metrics. And the difference between operational metrics and the other metrics is that they have to be monitored on different timescales. This figure here shows operational metrics, and we are interested in the last 24 hours. These operational metrics contain some classical DevOps metrics like the CPU load, memory load, and latency of the endpoint. But we also have machine learning related metrics. A very useful metric for us is the prediction score of the classifier. The score tells us something about the likelihood of the model output. And although we could not use this to detect if a prediction was correct or not, by observing the plot, this is for us a really good indicator if there were some bugs in the model or in the service if we deploy it again. And then the graph will suddenly changing. Other metrics that we use are, for example, training data metrics here on the top. We are, for example, interested in distribution of classes, in training statistics like the distribution of the classes, to understand our classification problem better. What I mean with that, you have to mention that our catalog is not constant, it's constantly changing because we have content colleagues which can add classes, which can delete classes, for example, categories, and by observing the distributions of the categories, we see if the evaluation metrics make sense or if the drop is caused by another issue. Yeah, and on the below, you see some model metrics. On the left side, you see a typical F1 score, and on the right side, a long-term prediction score. These metrics are measured over months because our training period takes around 2 weeks. And these metrics, not the prediction, but the F1 score, is measured by annotated offline data. On the left side, on this F1 score, you see a nice example of a model drift. And in the middle, you see that there were some manual investigations where we fixed the model drift. And on the prediction score side, you see there like this drop, the drop in the prediction score. This was actually not an error in the model or service. Here we had a shop which was recomputed, and this shop had, I would say, bad offers that do not fit so well to our classifier, and there we had some problems. So as you see, these are nice indicators to do further investigations to see, okay, there was something wrong. Do I have to look in the model or into the data? All right. Another important technique is logging, of course. Logging helps us to keep an eye on our services. We log to an OpenSearch cluster, and we create these nice Kibana boards. And we use OpenSearch because it allows us to build central dashboards that contain Python and Kotlin services so that all of our team can be represented in one board. And the goal of these boards is that they can be monitored and interpreted by each of our colleagues, as I said, regardless if the person works in Kotlin or Python, is our product owner or our team lead. Yeah. And with that, I would like to come to an end. I hope that we could give you some insights about our testing strategies. And of course, there exist a lot of more tests in the field of machine learning and in the field of software testing. but finding a good balance between the amount of work putting into the tests and into the development is very challenging. And this balance point differs from use case to use case. That's something that we learned. We identified 3 test domains, the traditional software tests, sorry, the cloud-related tests, and also the machine learning-related tests. And we hope that we could show you a little bit that, of course, monitoring and logging is very important for a safe and stable life cycle. And finally, let me share you this observation. In the recent years, we see that AI has attracted a great deal of attention in lots of areas, not at least because of the accessibility of generative AI, of the accessibility of models on Hugging Face or packages that we could use. But we find that solidating the test strategy in AI will be a necessary next step. We want to put, if you want to put research outcomes into productions, and if you want to make reliable systems out of them. So we are looking very forward when there will be more standardized paradigm in testing, because we believe that testing is a key for reliable, secure, and maintainable software product. Okay, thank you very much. Forget to mention that the slides are available at the Prelux site, so on our abstract.
Thank you. So we ended early, so we have time for a couple of questions. And also, I've been waiting to make this joke. So that's a pyramid scheme of safety that you shared with us today. And with that, let's get to the questions. The first one, could you implement contract tests with something like Pydantic or JSON schema?
We use Pydantic to define our schemes, and then also Pandera to, Pandera were not for the contract test, Pandera were for the data validation, but we use Pydantic. Yeah.
Okay, thank you. Next, you mentioned you automatically update your dependencies and requirements. How often do you encounter compatibility issues with ML-related libraries?
Quite often, yeah, and if this happens, we have to fix it by hand, yeah, so by manual investigation, see what's the real problem, yeah, but this happens at least a few times a week.
That sounds painful. Do you have a team of ML ops engineers and data ops engineers to help you with all the works? If so, how big are the teams?
No, actually, idealo is structured so that the team has an end-to-end responsibilities. We have a kind of a machine learning core team which helps us with the start of a machine learning product, but ML ops and also the further development in machine learning is done by the teams, which from my point of view is a great advantage because we could be really, really fast. Disadvantage is that you need different kind of persons in a team. Yeah.
Okay. You regularly retrain models. Are they pushed to production automatically or require manual intervention or quality check?
In most use cases, we deploy it automatically, yeah? But of course we got some validation limit. If the model doesn't does not fit the validation test, then it will not be deployed. But in usual cases, it's going to be deployed online. Yeah.
Okay. Where and when do you run the different types of tests?
Actually, everything is run by GitHub Actions. We're starting with unit test, linting, and contract test because we want to fail them fast, and also data validation. Then the infrastructure as code tests and the pipeline end-to-end test. So infrastructure as code test is also in the similar level on GitHub Actions. Then if we see if everything works, then we run the pipeline test because they take a while. And the deployment end-to-end test is like the last piece in the deployment pipeline where we deploy our services, because then we have like the stress tests and all the stuff. Yeah, I hope this answers the question.
Okay. Are you applying these steps on all of your use cases, or is this just a very mature, long-running solution already?
We started with one use case, and we felt it looks good. We felt safe with this solution, and then we on a way to extend it to all other use cases. Yeah, but started once where we thought it's the biggest need.
There is a room for an additional triangle in your pyramid. How do you manage integration tests going from dev database to int database and then prod? Integration tests from dev to prod.
Actually, what we are doing is like we have everything in our production environment. The problem, because we are running like 24/7, and we are not able to create a staging system because this would be too expensive. So that's why we try to secure as much as possible and to add as much as possible tests so that if the model is in production, we are really, really sure that it works. It could be that the performance is a bit lower, but it works in general. So no, we don't. Actually, the place is just because we want to have a pyramid out of that.
We appreciate that. If you depend on an endpoint of another team, how do you test or enforce that they not change the scheme without you noticing?
Contract tests. So we do not depend on endpoints, we depend on Kafka queues, and this is done by our software colleagues, and they are far more experienced in all the testing, and the tests are more solidated, so we use contract tests, and if another team wants to change something, then the contract test has to be passed, because we define the scheme. So, so there's a communication between that. Yeah.
Okay. Which tool, library, or package do you use for snapshot tests?
Snapshot test is done by NPM and CDK.
Yeah.
Yeah.
Okay. In which scenarios do your deployment, endpoint, and model predictions differ?
If you mentioned what Gunnar said, so we had a case that we trained a classifier with an XGBoost version. And so we stored this model somewhere, and then because this was an early phase, then we deployed this model. And something went wrong. What we didn't take care of is that XGBoost improved. So there was a bug fix in XGBoost, and we used the improved version for the service deployment. So at the end, the predictions which came out of the classifier are different from the model training, although we didn't have changed the code. And this makes us curious, and that's why we every time keep a little bit of data and test it during the deployment. Yeah.
Yep. That makes sense. Are you performing all the monitoring and logging, or is that part of the responsibility of some other team?
No, it's our responsibility. So we implement we think about the metrics we want to monitor, and logging is all in our team.
The good thing is because we are kind of diverse team in terms of what we're doing. So we have experienced software engineers who can set up this cluster for us. We're just using it, and we do it because they have done it before with their software engineering skills. Yep. Yeah.
It would be painful without them, right?
Yeah.
Yeah. Have you considered to use SageMaker auto-scaling to cope with high traffic volume? Wouldn't this make model stress tests obsolete?
We do use auto-scaling, but this doesn't make the stress test obsolete because the problem on the stress test is that our batches can be, so we compute everything at idealo in like 3 weeks, and then we get really, really high batches. And we thought that these batches, because of these batches, it came to memory breaks. So it tried to allocate more memory than we had. And this cannot be, also the auto-scaling wouldn't work so much because auto-scaling takes a while. I guess the problem here is that we want to make our services, or we want to fit our models so tight in the services, so we try to allocate small instances because of pricing and all stuff. So this is like we did the testing, yeah. And we do auto-scaling, of course, yeah.
All right. There are just a few more questions, but I think we're up on time.
We're around here, yeah.
Yeah, if you have more questions, find them.